Okay, welcome to part 3 of our asymptotes video. This is the shortest of the 3 videos, and in this lesson we're going to be looking at oblique or slant asymptotes. So while we've looked at vertical and horizontal asymptotes before, we have not looked at obliques. However, these are one of the quickest ones to determine the value of. And so oblique or slant asymptotes are our asymptotes that are at an angle, and so you'll notice it's a linear function. So it's going to be written in the form y equals mx plus b. Now, these again are for rational functions, but we can determine if a slant asymptote exists before we even start doing any calculations. So slant asymptotes occur when the degree of the numerator, so it's important the degree of the numerator is exactly 1 degree higher than the degree of the denominator. And so we would look at the degree of our numerator. For example, if we look at the picture here, the degree of our numerator is 2. So if you remember, degree is if we were to arrange our polynomial in algebraic order, the highest exponent dictates the degree. So here our highest exponent in the numerator is x squared, so the degree is 2. Down here our highest exponent is x to the 1, so our degree is 1. So the degree of the numerator is 2, the degree of the denominator is 1, so this tells me that there will be a slant asymptote. Now, slant asymptotes can be found using either long division or synthetic division. I'll go through both examples. It does not matter to me which method you use. I'm guessing that most of you are quite comfortable with synthetic division from Math 30-1. So again, it doesn't matter which one you use, but I'll show you both examples. And then once we've done that synthetic division or long division, our final slant asymptote will be written in the form y equals mx plus b. All right, so let's take a look at our first example here. We're asked to find the slant asymptote for f of x equals 3x squared minus 2x plus 1 over x plus 2. So the first thing we have to do is make a little bit of a checklist. Is this a rational function? Yes, it is. Is the degree of the numerator exactly 1 degree higher than the degree of the denominator? And so we're looking at the degree of the numerator versus the denominator. And so if we look at the degree of the numerator, we've got 3x squared minus 2x plus 1. So the degree of the numerator is 2, and the degree of the denominator is 1. So this fits as well. Now, if we could factor and break things down, we would do that, but in this case, we can't. So factor if possible. So we're going to start off by using synthetic division. And so if you remember with synthetic division, we're just looking at our coefficients. So we've got a 3, a negative 2, and a positive 1. So we're going to have 3x squared minus 2x and positive 1. And then for our factor on the outside, our factor here is x plus 2. So that means that if we set that equal to 0, x equals negative 2. So we're going to divide by negative 2. All right, so if we were doing our division here, we're going to bring the 3 down, and 3 times negative 2 is negative 6. And then we add. Negative 2 plus negative 6 is negative 8. Negative 2 times negative 8 is negative 16. And sorry, positive 16. Negative 2 and negative 8 is positive 16. And so if I add those two together, 1 plus 16 is 17. So that's my remainder. Now, when I have a remainder, that doesn't affect anything in terms of our asymptote. So you are allowed to have a remainder. Okay, so if we look at our final answer here, we would have 3x minus 8 as our asymptote. So y equals 3x minus 8. Now, if you were to look in your textbook, it'll go into more detail in how we deal with that remainder, but ultimately this is always your equation. So y equals 3x minus 8. Now we can do this exact same example using long division. So if we wanted to do this using long division, we would take the 3x squared minus 2x plus 1, and we would divide by x plus 2. And so I've seen different examples as to where we put our terms on the top. I was always taught to match my terms vertically, but I've seen others who just write them right from left to right. So it doesn't matter to me as long as you're getting the correct answer. So x plus 2, 3x squared divided by x, we would need to multiply by a 3x to get 3x squared. So I'm putting my 3x right above the x. Again, I've seen others that just start writing it left to right. As long as everything's balancing out, you're fine. So 3x times x is 3x squared. 3x times 2 is a positive 6x. Put your brackets and subtract. 3x squared minus 3x squared is gone. Negative 2x minus 6x is negative 8x. We'll bring the 1 down. And in order to get negative 8x, we're going to have to multiply by negative 8. So we're going to have negative 8x minus 16. So negative 8 times 2 is negative 16. And if we subtract, we're going to have 1 minus negative 16, which is a positive 17. Again, we're not worried about the remainder. We're looking for our equation. And so our slant asymptote will be 3x minus 8. Okay, we're just going to look at 2 more examples following the same method. The first one here, it says find the slant asymptote for y equals x squared plus 1 divided by x plus 1. So our coefficient here, we've got a 1. Notice there's no x term in there, but we're still going to have to account for that in our synthetic division. So we're going to have x squared plus 0x plus 1 all over x plus 1. So in our synthetic division, that gives us a coefficient of 1, coefficient of 0, and our constant of 1. Divided by x plus 1 means that negative 1 is what we're dividing by. So we bring down the 1. And negative 1 times positive 1 is negative 1. 0 plus negative 1. 0 plus negative 1 is negative 1. And negative 1 times negative 1 is a positive 1. Don't make the mistake I did and write a 2. Okay, I went 1 times 1 and wrote 2 the first time I did this. Just silly mistakes to check out or to watch out for. 1 plus 1 is 2. Now again, that's our remainder. So our final equation is going to be y equals x minus 1. And so if I were to graph this, if I wanted to graph and determine where the oblique asymptote was, I would have an asymptote there at y equals x minus 1. Now the last question here, example number 3, we've got 3x cubed minus 8x squared plus x minus 3 all over x squared minus 9. I'm going to do this one using long division. So again, just so that you can see some other examples, we've got 3x cubed minus 8x squared plus x minus 3. And that's all divided by x squared minus 9. So we look and ask ourselves, what do we need to multiply by the x squared to get to a 3x cubed? And we need to multiply by 3x. So 3x times x squared is 3x cubed. 3x times a negative 9 is negative 27x. And this is a 0x squared. So sometimes you'll see people leave that space blank. I find it's helpful to fill that in. So 3 minus 3 is 0. Negative 8 minus 0 is negative 8x squared. 1 minus negative 27 is a positive 28x. And we bring down the negative 3. So what do we need to get to multiply by x squared to get to a negative 8x squared? Well, we're going to multiply by negative 8. So negative 8 times x squared is negative 8x squared. Negative 8 times negative 9 is positive 72. And we've got a 0x. So negative 8 and negative 8 cancels out. 28 minus 0 is just 28x. And negative 3 minus 72 is negative 75. So this is our remainder. But again, the remainder isn't what we're worried about. We're looking for our equation up here. So there will be a slant asymptote at 3x minus 8. y equals 3x minus 8. Now, I would encourage you to actually graph this on your calculator. This is really a neat looking graph. And then graph y equals 3x minus 8, and you should notice that that's where your asymptote falls. All right, so that is our video on slant asymptotes. Hopefully, you've got a good taste of how to do each of the 3 types of asymptotes. And if you have any questions, I'm always available in class. Thanks a lot, guys. Have a great day.